This is ControlForge, an IEC 61131-3 runtime written in Go. What you're looking at is the entire development environment running in a browser tab against a controller that's already scanning. There's no client to install, no license dongle, no version of the IDE that has to match the version of the firmware. Any machine with a browser is a programming terminal, a new POU. If you've worked in any 61131 environment, this part is exactly what you'd expect, and that's deliberate. There's nothing to relearn. Structured text goes in over the starter template. A bottle filler as a 4-state sequence: idle, index, fill, count. 2 ton instances, one for the index move and one for the 3-second fill. Nothing exotic here, and that's the point. A case on an INT, timer instances declared in the var block, and on delay, you'd write the same way on any platform. No vendor dialect, no proprietary extensions. And the source itself lives on the controller. The editor reads it straight back from the PLC, so the machine is never the one artifact you don't have the code for. Then the task. A 100-millisecond periodic scan with the POU placed in its execution order. Priority, watchdog interval, and what happens on a timeout are all per task. So a fast interlock loop and a slow reporting routine don't have to share a scan. Execution order inside the task is explicit and editable, which is the part that bites people when a project grows and 2 POUs start fighting over the same tag. Then validate and download. Notice what isn't here. There's no compile step and no build artifact to keep track of. Validation checks the project, the download hands it over, and the in-sync badge is an actual hash comparison between what the controller holds and what the IDE holds. Online, and the editor is attached to live memory. Every variable in scope is listed right beside the code and updating as it scans. The state, the bottle count, the valve, and both timers with their preset and elapsed. And now it's stopped. That breakpoint was set by clicking the gutter next to the count line, and the task is halted on it mid-scan. The call stack tells you where execution is, and every one of those values is frozen at that exact instant rather than sampled sometime afterwards. Step over, and the current line advances while the values follow it down. Step again. Then continue releases the task, and the filler picks straight back up. The other tasks never stopped scanning while this one was held. Running again, with the breakpoint still armed for the next time round. That's the whole loop. Write it, put it on a task, download, go online, and break on the line you actually care about. All of it in a browser tab, against a machine that never stopped running.